Hey guys, welcome back to AlgoYogi. We are doing tree series, and this is our last problem in the list. It's LeetCode hard. Let's go to the problem. It's called Serialize and Deserialize binary tree. So I'm sure you have already read the description. So I'm not just gonna read it line by line, but I will tell like what the problem is actually asking us. So we are given a tree with the root node reference, and as you can see here in this first example, this is the binary tree that they have given us, and now we need to write code for two functions. It's basically the implementation kind of problem where the interviewer will basically ask you to implement like a class and its a method. So here we need to implement two methods. First is serialize. So we are given the root of the tree. A tree is given. We need to serialize it, and that means we need to encode it, the entire tree, into a string, a single string, in such a way that later when this string is given to us without any root reference or any node reference, we can again make the same tree. Right, it sounds complicated, but it's actually not. If you already know, like how you would basically stringify, it's all about stringifying a binary tree and then just deserializing it from that particular string. So let's go into it, how we're going to do it. So let me switch the view. All right, so as you can see the first example here, so we need to serialize this, basically convert it into a string, and one of the ways is to first is like traverse the tree in order, pre-order, post-order, or level order traversal. And I think in this case it would be better to traverse it pre-order, in which we are visiting the root first, so that whenever we are visiting a node, we are basically utilizing that value and then trying to access its left or right, and if they do, then visit those. Otherwise, just append into our string a null pointer or like null value, or in this case we could just append n. So let's say I am writing the serialize function. First I visit, and I'm using pre-order traversal. Now I visit root node, then I'm basically appending it to my string, going left, appending it to my string, going left, it's null or none in Python, then going to its right, because I have already visited my root, so this is done, and this is done. However, like this is being visited currently because its right side hasn't been explored yet. Now that will also become none. Again, coming back to this node, visiting, then going to left, right, so n, going to this side 5, and then n and n. The reason I'm appending these, so that even if there is no value, I need to know when I'm deserializing it if that is if a node is a leaf node. And how would you know that? When you have the value and its left placement and right place, they are basically are represented with n. N means none. So now this we have created. Now we have to convert it into this tree. How are we going to do it? We have done pre-order, we got our string, and serializing was easy. How we are actually converting this string to our tree now. You know what? Same way. We're gonna start visiting, since we did the pre-order traversal. So first node we're accessing, that we know for sure it's going to be the root. So we create the root, then we visit next pointer, which will be the left side of it, left child. Then 2 will take this place. So this is 1, this is 2, And let me just change the color here. This will become 2. Now 2 needs to be visited. Let's go to its left side. This is none now. And if it's this is none, then this side doesn't have to go any further. It's only its right side now. Its right subtree, which is also none. Then this is a leaf node. Return back. We're returning back to our root node 1, and now we're gonna do its right side. So we're gonna start doing 3. Then 3 is done. Then 3 is left. Would be 4. 4 is left. Basically none and none, which means get back here, process its right side. 5 and then none and none. And beauty of pre-order traversal is like you don't have to go back to the root. You just basically tail out from this recursion. And this is it. This is, I think, like doing it using pre-order is quite really simple. You do not need to like have these other pointers that you don't basically need 2 string to maintain it, right? You just need 1 string, which is pre-order traversal of the array, including the null pointers. Do not forget this. Append n, append null, append none. All of them is string, of course, but just append them, or n. If you don't append them, then you would have no way of stopping somewhere and feeling that you're done with that particular node, and just it's the time to get back to your root. All right, let's quickly code it up. As we said, we're going to have, let's call it tree. I'm just going to have a list so that, and we are implementing pre-order, so let's have pre-order DFS. That's going to take root. And let me make the code a little cleaner here, and I made it more messier, but anyway, now it's all good. So if root is none, that means I will append, so tree dot append n. That's for the none nodes, right? And then just return it from here. Otherwise tree will take, we're gonna append the string, not just root value, that's integer. So a string of root dot value, and let's do it on left and right side. No, don't run. Oh my god, I don't know what it did. I think there is some shortcut that makes it run. Okay, let me just focus on the code, right? I think that's pretty good. I know I need to go over here, but left and right, no, it's right, not oh my god, right. Okay, and then what do? We are kind of done, right? We are returning, this is done, value is appended. Let's call pre-order on our root, and then our tree must be filled up, so we just return, let's append all, not append, join them. So if you provide list in after this join function, then it will append all the string values inside that. So this will give us the string. It will stringify in pre-order traversal our tree. Now we gotta deserialize this. Let's have a pointer. Let's call it self, or maybe we don't need that. We just let's have the helper function. Let's call it DFS, which is going to take the index I. Initially it will pass to 0. That's what we are processing. Later it will keep incrementing. So for example, now if data at ith is what? If it is n, that means we return none. And also let's have a check. If I is not like that. I think if I is greater than equals to len data or I think in this case also it should return none, because we might reach at a position where although it should always have all the values because that's how we designed it, but I think this is like an edge case you are trying to have. Maybe I'll delete it later and test it, okay? But now I'm currently thinking that this, if I'm writing my solution, like I would want to be like all these error prone to these errors, okay? Now what? None is returned. Let's process the root. Root will be at data, and that's how we're gonna convert the root. So that's like, I don't have root, come on, I have data at my ith position. Also, before we returning this, we need to increment our I pointer because we have utilized that n. So we're gonna increment that. All right, 1. Am I going to have access to this? Like, yeah, hell yeah, hell yeah. No, I don't need this here. I'm so sorry. This is not what I'm accessing. I'm just, root is done at ith. Now root dot left is going to be dfs at I plus 1, and same way this will be done at I plus 1 also. Now I'm thinking, because for right side also it's gonna go at I plus 1 and I plus 1, but then it's trying to access the same value. Then maybe let's take it out. Let's make it a global thing. So self.I, I'm gonna just, taking it out. Self.I initially 0, then we don't need to pass it, only need to increment it. Self.I plus equals to 1, and one time let's increment it over here whenever it's returning from there, so it goes to the next pointer itself. So if we do it there, we don't have to do it here, and that's because we're already incrementing. If from left we are basically returning none, then we don't have to increment it over here. All right, then I think that is okay. Self.I. What else? Are we missing anything? I don't think so. Then this is down. Let's call dfs just like that, and not just like that, we're gonna actually return it, because we're gonna return root from here. Return root. All right, that's what we created over here, and we assigned left and right children to it. So let's return this. Let me zoom out. Hopefully it is all good. I'm gonna run it on the example. My mouse isn't working very well, but anyway, my examples are right. Then please, so there is some issue, and that is because of did I forget to for -1? Oh, what if there were some negative values? Then I think I didn't do a very good job in my data, right? I think there should have been some delimiter like this, that should have done the job. Okay, let's have some delimiter what cannot be part of our data. Let's say dollar. Okay, so now I'm gonna just assign my data equals to data dot split, and I'm just gonna provide the dollar. That is that's hash dollar. All right, let's submit it now, and I am assuming this will be accepted. Wow, I'm sorry, I'm just stupid. All right, let's write the time complexity. Time complexity would be big of n visiting all the nodes processing all the nodes. Space complexity will also be big O of n. That is because we are storing it, all the nodes, including nonce, right? Well, let's go back to AlgoYogi. This is the last problem. I know you can't see it, but I'm marking it solved, just like I've marked all of these problems solved. I'm marking this one also solved. Now this is done, and after completing this, we have solved 54 problems of trees. Next topic would be linked list, and we're gonna do it really quickly. There are only not much problem. I'm not gonna count them, but but we'll find out like how many problems. I think maybe like I can append a number of list problems over here, problem category. I'll do it. All right, until then, bye bye, tada. See you guys later. Why is my this thing no